Blazor WebAssembly is a single-page app framework for building interactive client-side web apps with .NET. It uses open web standards without plugins or recompiling code into other languages. This course will teach you how to use Blazor WebAssembly and Web API on .NET 6. You will learn step-by-step how to build a shopping cart application. This course also provides a guide on how to integrate a payment gateway into your Blazor WebAssembly component, so that a user is able to pay for products through your application using a debit or credit card or even a PayPal account. Gavin Lawn teaches this course. Gavin is a senior software engineer with over 20 years of experience. I encourage you to leave a comment with the most interesting thing you learn for the benefit of other campers who are watching this course.
Please join me as we build a very basic shopping cart application using Blazor WebAssembly. A few of the significant technologies we'll use for building our application are as follows. The latest version of Visual Studio, which is Visual Studio 2022, and we'll use the Community Edition for Windows. .NET 6, which is at the time of creating this video the latest version of .NET. It was released in November of 2021. SQL Server 2019. Blazor WebAssembly. We'll use Bootstrap version 5 for layout and styling purposes. We'll build a RESTful MVC Web API project for handling database-related functionality and returning relevant data from the server to our client-side Blazor application. All technologies used for the development of this application can be downloaded free of charge. Please see below in the description the locations of where you are able to download the relevant technologies for free. We are going to integrate a payment gateway powered by PayPal into our application, so that a user can use their PayPal account or a valid debit or credit card to pay for the items that are purchased through our online shopping cart application. Blazor is a relatively new feature of ASP.NET. It offers two hosting models, a server-side hosting model and a client-side hosting model. We are going to use the client-side hosting model for the development of our shopping cart application. The significance of this hosting model is that the C# code runs directly within our browsers. What makes this possible is a technology named WebAssembly. In recent years, the creation of SPA applications or single-page applications have become very popular as web solutions. Up until fairly recently, JavaScript frameworks like Angular or React have been the available choices for the creation of SPA applications. With Blazor, we are now able to create our single-page applications using C#. We don't necessarily need to depend on JavaScript for the creation of our interactive UI code. We can create this code using C#. In this application, however, the payment gateway provided by PayPal is coded in JavaScript. So we will use Blazor's interoperability functionality with JavaScript to interact with the relevant JavaScript PayPal code. So let's get started. Let's create our Blazor solution. Let's fire up Visual Studio 2022. Select Create New Project. Let's choose the appropriate project template. Blazor WebAssembly app. Let's name our solution Shop Online Solution. Let's name the Blazor project shoponline.web. Great. Let's add a new project to our solution where we'll create our RESTful Web API functionality. So let's ensure that we choose the correct project template. Let's name our project shoponline.api. Notice that for the authentication type, we are choosing none. We are not going to implement membership functionality, which of course includes login and registration functionality. We'll focus purely on the shopping cart functionality. We want to run our application on the latest version of .NET, .NET 6. Note that we have enabled Open API support. By doing this, the Swashbuckle NuGet package will be automatically installed, and the appropriate Swagger middleware will be automatically configured appropriately within our project. One of the advantages of this is when we run our Web API project interactively, we'll be able to test our Web API code through our browsers even before we have developed any front-end code. So a basic UI will automatically be created for this purpose for us. When we run our application interactively, we'll be able to test each of our action methods through the relevant automatically created web-based UI. Note that you can also use a tool like Postman to test your Web API functionality. I won't be using Postman during the development of this application. We are going to build our database using code-first migrations and Entity Framework Core. Migrations allow us to evolve our database without losing data or database objects. So by using plain old C# classes, we can build the database entities that we wish to include within our shopping cart application. Once we have created relevant entity-related C# classes, we'll look at an entity relationship diagram that represents our shopping cart application's database design. Let's add a folder named Entities to our project. This is where the classes that will represent our database entities will reside. So let's create a class named Cart to represent the cart entity. So let's add two public properties to this class: ID as integer and user ID as integer. Let's add a new class named CartItem. This entity represents an item that has been added to the user's shopping cart. So let's add an integer property named ID. Let's add an integer property named CartID. This property represents a foreign key field and is used to join the cart entity to the CartItem entity. So the cart entity has a one-to-many relationship with the cart item entity. This denotes that many cart items can be included within one particular shopping cart. Let's include an integer property named product ID. Lastly, let's include an integer property named QTY, representing the quantity or number of a particular product that may be included within a particular shopping cart. Let's create a new class representing the product entity. The product entity will have a one-to-many relationship with the cart item entity. This denotes that a product can be included many times across many different shopping carts. Let's add an integer property named ID. Let's add a string property named name. Let's add a string property named description. Let's add a string property named image URL. Let's create a property of type decimal named price. Let's create a property of type integer named QTY. Lastly, let's add a property of type integer named category ID. The category ID property represents a foreign key from the product category entity, the code for which we are about to implement. So let's create a class named product category. This entity has a one-to-many relationship with the product entity. Let's add a public property named ID. Note that when a property is named ID, by convention, Entity Framework Core will designate the ID property as representative of the relevant entity's primary key. Let's add a property of type string and name this property name. And lastly, let's create a class to represent our user entity, which of course represents a user of our application. Note that I've included this entity as a temporary substitute for a membership facility, like for example, Microsoft Identity, so that we can focus on the shopping cart workflows and not be distracted by the membership functionality. So let's add an integer property named ID. Let's add a string property named username. So if we look at this entity relationship diagram, we can see the relationships between our entities. The cart entity has a one-to-many relationship with the cart item entity. The product entity has a one-to-many relationship with the cart item entity. The product category entity has a one-to-many relationship with the product entity. The user entity has a one-to-one relationship with the cart entity. So this basically means each user can only have one shopping cart within our application. If you look at the SQL Server Management Studio that is installed on my local machine, you can see that I've already generated a database through EF Core. This was done when I was developing the prototype for this application. So we are now going to use EF Core to generate a database for our shopping cart application. The classes that we have just created, representing our entities, will be used by EF Core to generate the corresponding database tables within a database that EF Core will create for us. In order to generate our database with the relevant tables through Visual Studio, let's install two NuGet packages. To do this, right-click the Dependencies node within our shoponline.api project. Click the Manage NuGet Packages menu item. Click the Browse tab on the NuGet Package Manager dialog. Let's search for Entity Framework Core.SQL Server. And this is the package we want to install. Let's click the Install button, then the I accept button. Great. Let's search for the second package that we need to install. The reason we are installing this package is because we want to run our migrations from within Visual Studio, as opposed to using the .NET CLI for this purpose. Note that you would use different commands when running migration commands using the .NET CLI, as opposed to the commands you would run when using Visual Studio. So let's search for Entity Framework Core.Tools. And this is the package we want. Let's install the Microsoft.Entity Framework Core.Tools NuGet package. The next step is we must configure a connection string in order to connect our application with the database that we wish to create using Entity Framework Core code-first migrations. So let's open the appsettings.json file within our shoponline.web project. Within the connection string that I'm configuring here, I'm including my server name, which is Gavin Lon's PC, the database, which I wish to name Shop Online, And we are going to use a trusted connection to connect our shopping cart application's web API to our database. So let's include trusted_connection equals true within our connection string. Note that I have named my connection string Shop Online Connection. Let's create our database context class. Let's first create a folder named Data within our shoponline.api project. Let's add a class named shoponline_db_context to our new data folder. So in order to make this class represent our EF Core database context, we need to implement code so that our shoponline_db_context class inherits from EF Core's db_context class. You can see there's a red squiggly line under db_context. This is because we haven't yet brought in the Microsoft.EntityFramework Core namespace. An easy way to include the appropriate using directive through Visual Studio is to press Ctrl- and then select the appropriate menu item from the menu that is presented to us through Visual Studio. Let's create the constructor for our shoponline_db_context class. We must add a parameter to the constructor that we have just generated. The parameter is named options and is of the generic type db_context_options, which has the data type shoponline_db_context passed as an argument to it. We can then write code to pass the argument that will be passed to our shoponline_db_context class constructor to the base class from which it inherits, i.e. the db_context class. Now, because I want to focus on the shopping cart workflows at this stage, and don't want us to be distracted by the implementation of administrative CRUD operation functionality, we are going to seed our database with certain data. This is data that I've already prepared. So we are not going to include create, read, update, and delete functionality regarding the creation and maintenance of product data at this stage. We are going to seed our database with product-related data. We are going to seed our database with the relevant data so that we can move directly to the creation of our shopping cart functionality. So in order to seed the database appropriately, we can override a method that exists within the db_context base class. This method is named onModelCreating. An easy way to generate the relevant override code for this method through Visual Studio is to type in the word override and then press the spacebar. We can then select the onModelCreating item from the drop-down list presented to us within Visual Studio. I have already prepared the code for seeding our database, and this code can be found at this location on GitHub. So let's go to the appropriate GitHub location and copy this code to our clipboards. Let's then paste the code from our clipboards into the onModelCreating method. The next step is to let Entity Framework Core know, as it were, about our entities. So we can do this by using the Entity Framework Core dbSet generic type. So for each of our entities, we need to appropriately include a public property of type dbSet within our Shop Online DB context class. To register our Shop Online DB context class for dependency injection, let's open the relevant program.cs file. Then we can simply add this code here to register our Shop Online DB context class for dependency injection. Note that our code is reading the connection string that we configured in the app settings.json file. We are now ready to generate a migration using EF Core. So let's launch the NuGet Package Console Manager window from within Visual Studio, like this. We can then type the appropriate command to generate a migration. So let's type in add-migration followed by the name of the migration we wish to create. So when I run the add-migration command, I get an exception. I've found out that this exception occurred because at present the shoponline.web project is set to my startup project within the relevant solution. So if you get this exception, all you need to do to fix this is make the shoponline.api project your startup project, like this. So let's try again. And now we don't get the exception, and it works as expected. And you can see code within the up method of the migration class that we have just generated. This code creates our database and the relevant tables. This method also contains code that seeds the relevant database tables with the data that I prepared prior to creating this video. The down method contains code to undo the changes made by code contained within the up method. To run our migration, all we need to do is type the update-database command within the NuGet Package Manager console window, like this, and then of course press enter. And now, if we look at SQL Server Management Studio, we can see that the Shop Online database has been created. The database tables have been appropriately created based on the entities we created using C# classes. The relevant database tables have been seeded with the data created from the code we included within the onModelCreating method, which resides within the Shop Online DB context class. The data with which we have seeded our database contains product and user information. This has been done so that we can focus on the shopping cart functionality and not worry at this stage about implementing code for create, read, update, and delete functionality regarding products sold by our fictional online store. Here are just a few notes about running migrations. Please note that if you have run a migration or more than one migration and are not happy with the changes made to the database, you can undo the changes made by running this command, update-database followed by a 0. The number 0 is a special case that means before the first migration and causes the effects of all migrations to be rolled back. You may wish to remove the migrations after this. You can remove a migration that has not yet been used to update the database by running the command remove-migration. The remove-migration command will remove the last migration that has not yet run. Note that if, for example, you have updated the database with multiple migrations, and you wish to roll back the changes to before a particular migration was run, you can roll back your changes to that particular state by running the migration that was run directly before the migrations that were run that contain the changes you wish to roll back. This is the second part in a series of videos dedicated to building a shopping cart application using Blazor and a RESTful web API. In this video, we are going to start with the workflow that involves retrieving product data from our database and returning the data to the client Blazor component. The code for this functionality will be implemented within a web API component. So in this tutorial, we'll start to develop our web API component. Before we do this, let's create the classes that represent the data that will be passed between the web API component and the Blazor component. You might be thinking, but we have already created the classes to represent the data for our application, for example, product, product category, cart, cart item, etc. Yes, we did create these classes that represent our entities in the previous part of this video series. These entity classes directly map to the database tables that were generated when we ran the relevant migration. The function of these classes can be seen as blueprints for their corresponding database tables. When we pass data between the web API component and the Blazor component, we don't necessarily want to pass the exact data defined by the properties in the classes that represent the database entities. For example, in this tutorial, we are going to create code that returns the product data from the web API component to the Blazor component. The product class contains certain product-related properties, one of which is the category ID. A particular category ID value could, for example, denote that a particular product falls under the electronics category and could, for example, be a laptop. Or, for example, the product could fall under the furniture category and could be, for example, a couch. The category ID property within the product entity is a foreign key from the product category entity. From a human perspective, the category ID property does not have much meaning because it contains a numeric value. So it wouldn't, for example, make much sense to display the category ID to the user. We may want to pass the relevant category name in addition to the product information defined in the product class. So to facilitate this, we can create a new model that contains all the relevant product data as well as the relevant category name, which is included in the product category entity and not the product entity. So it makes sense to create a new model to represent the data that in this case we wish to pass from server to client. We need a model that includes all the product information as well as the category name. The type of model I am referring to is known as a DTO, or Data Transfer Object. This type of model includes the data that needs to be passed between server and client. So a DTO is an object that defines how the data will be sent over the network. The classes that represent our entities that we created in the first tutorial directly map to their corresponding database tables. These classes represent the structure of certain tables in our database. We can create DTOs data transfer objects that are based on the underlying entity classes, but may be differently shaped based on the data that needs to be passed between client and server. We are going to create a standard library project to house our DTOs. So let's create a new project within our solution. Let's select the appropriate class library project template. Let's name our new project shoponline.models. Let's delete the default class generated for us by Visual Studio. Let's create a folder named DTOs. So let's create the DTOs that we are going to use in our application. Now, the only DTO that we are interested in at the moment will be named Product DTO. But let's create the other DTO classes that will be used later on in the development of our application, as well as the Product DTO class. The DTO classes will be explained in more detail at appropriate points during the development of our application. Let's create a class named Cart Item DTO. Let's make sure our new class contains the public access modifier. Let's create the properties for the Cart Item DTO class. ID as integer, Product ID as integer, Cart ID as integer, Product name as string, Product description as string, Product image URL as string, price as decimal, total price as decimal, and QTY as integer. Let's create a new class named Cart Item to add DTO. Let's ensure that our new class contains the public access modifier. So, Cart ID as integer, Product ID as integer, and QTY as integer. Let's create a new class named Cart Item QTY Update DTO. Let's ensure that our new class contains the public access modifier. Cart Item ID as integer, QTY as integer. Let's create a class named Product DTO. This is the DTO that we are going to use in this tutorial. Let's ensure that our new class contains the public access modifier. ID as integer, name as string, description as string, image URL as string, price as decimal, QTY as integer, category ID as integer, and category name as string. Great, so we have created the classes that represent our DTOs, data transfer objects. Let's go to our shoponline.api project. So we are now going to start coding the logic for our first workflow, starting with the Web API component. This workflow simply involves retrieving product data from our database and returning the data to the client Blazor application. The Blazor application will contain code that displays the relevant product data to the user. So now our Shop Online DB Context class has been registered for dependency injection. We'll see in a bit how we are able to implement code to ensure that an object of type Shop Online DB Context is injected into relevant classes. We are going to use the repository design pattern to abstract our data handling layer. Repositories are classes or components that encapsulate the logic required to access data sources. We can use repositories to centralize common data access functionality, which has the benefit of facilitating better maintainability, easier unit testing, extensibility, and cleaner code. The best way to understand the repository pattern is to implement the relevant code. So let's write the code for our product repository functionality. So let's create a folder named repositories. Within the repositories folder, let's create a folder named contracts. Within the contracts folder, let's create an interface named iProduct repository. Let's create 4 method definitions within our new interface. We want all these methods to run asynchronously, so all the method definitions within this interface will return generic task objects. Our first method is named getItems and returns an IEnumerable collection of type product. So the IEnumerable collection is passed as a type argument to the task object. As discussed, this is so the method that implements this method definition can run asynchronously. The other methods follow a similar pattern. Let's define the method definition for a method named getCategories. Let's define a method definition for a method named getItem, which contains a parameter of type integer named ID. Let's define a method definition for a method named getCategory, which contains a parameter of type integer named ID. So we have defined the interface that we want a class named product repository to implement. So let's create a class directly within the repositories directory named product repository. And the first thing we need to do is write the code to implement the iProduct repository interface. So let's do that. We can see a red squiggly line under iProduct repository. This is because we need to bring in the shoponline.api.repositories.contracts namespace. A quick way to do this is press Ctrl, and then select the appropriate item from a list provided by Visual Studio, like this. The red squiggly line is still there. This is because Visual Studio is telling us, as it were, that we need to implement code for all the method definitions that we have defined within the iProduct repository interface. So let's press Ctrl once again and select the appropriate item from the list presented to us. And Visual Studio generates the relevant code stubs for us. So Visual Studio generates default implementations for the relevant method definitions. So at this stage, we only want to implement the code logic relevant to the workflow that is the focus of this video, i.e. returning a collection of product data to the client side calling code, in this case our Blazor component. We are going to need to use the Shop Online DB context object to interact with our Shop Online database. As you will recall earlier, we registered the Shop Online DB context object for dependency injection. This means that we are able to gain access to an object of type Shop Online DB context by defining an appropriate parameterized constructor in our product repository class. So let's create the code for this. An easy way to automatically generate a constructor within Visual Studio is type CTOR and then press the Tab key twice, like this. Then in order to indicate to .NET that we want an object of type shop_online_db_context to be injected into this constructor, all we need to do is define a parameter within our constructor of type shop_online_db_context, like this. Let's bring in the appropriate namespace. And we can get Visual Studio to create an appropriate private read-only member variable to reference our shop_online_db_context object by pressing Ctrl- and selecting the appropriate item from the list presented to us by Visual Studio. Great. So for the workflow that is the focus of this tutorial, we only need to implement code for two of the method definitions within the iProduct repository interface. So at this point, we are only going to implement code for the getItems method and the getCategories method. So let's implement code for the getItems method. All we want this method to do is return all the products from the products table. So let's write the code for this. Note, we want our code to run asynchronously, so we must include the await keyword here. Notice how once we have typed in the await keyword, that the async keyword automatically appears in the method definition for the getItems method. If you include the await keyword within a method, the method in which you include the await keyword must appropriately contain the async keyword. Note that to include the toList async extension method here in our code, we must bring in the Microsoft.Entity_Framework core namespace. And that's it. We have written the code to return an enumerable collection of products data from our database. So let's implement the code to return the product categories from our database. We can do this by implementing the appropriate code within our getCategories method, like this. Great. So we have now implemented the code for retrieving product data from our database. The next step is to write code to return the appropriate data to the calling client. So to do this, we need to create an appropriate controller class. Before we create our controller class, let's delete these classes that were generated by default when we first created our Web API project. These classes are obviously not going to be used in our application. So now let's create a class within our controllers directory. Let's ensure that we select the appropriate controller class template. Let's name this class Product Controller. So the first thing to do is to write the code so that an object of type product repository is automatically injected into our controller class's constructor via dependency injection. Let's also ensure that we have a read-only private field that references the object passed in via dependency injection. But we haven't yet registered our product repository class for dependency injection. So let's write the code for this. Let's open the program.cs file. Let's implement the code to register the product repository class with the dependency injection system. Notice how we use the add_scoped method to register our product repository class for dependency injection. We could have used the add_transient method or the add_singleton method to register our product repository class with the dependency injection system, but in our case, add_scoped is the appropriate method for this purpose. Very basically, using add_transient would mean that a new instance of the relevant object is provided to every class that requires the relevant object to be injected. Using add_singleton would mean that the same instance of the object is injected into the relevant classes for every HTTP request. Using add_scoped means that the same instance of the object is injected into relevant classes within a particular HTTP request. Note that in this case, a new instance of the relevant object will be created for each HTTP request. Let's create a method definition for an action method named getItems. We want our action method to run asynchronously. The type that is passed to the generic task object is of the generic action result type. One of the core benefits of returning an action result is that, as well as returning the requested data from an action method to the client, an appropriate response status code can also be returned. For example, a HTTP status code of 200 means the request has succeeded. A status code of 404 represents that a resource could not be found, and a HTTP status code of 500 represents that an internal server error occurred. So we need to pass the type of data that we wish to return to the client as a type argument to the action result generic type. So we want to return an IEnumerable collection of type product_DTO to the client. So the first thing we need to do is create a project reference to the shoponline.models project, because this is where our product_DTO class resides. Then let's bring in the shoponline.models.dto's namespace. Great. Let's name our action method getItems. Each action method in our controller must map to a particular HTTP verb. For example, get, post, push, delete, etc. Our getItems action method will be used for getting product data and returning that product data to the client. So the appropriate HTTP verb for this action method is get. So to indicate this to .NET, we need to decorate our getItems action method with the HTTP get attribute. So let's implement the code logic for our getItems action method. Let's first create a try-catch block. An easy way to do this in Visual Studio is to type in try followed by pressing the tab key twice. So let's write code that calls the product repository class's getItems method asynchronously to return an IEnumerable collection of type product to our action method. We want to include the category name associated with each product in our collection, so let's write code to return a collection of product category objects to our action method. We'll write the code that joins our collection of products with our collection of product categories in a bit. So you may have spotted that the code in this action method is not ideal at the moment. It is not ideal because we are retrieving a collection of products and a collection of categories in two separate queries to the database. A more performant way for retrieving the product collection and related category data would be to appropriately use the include extension method within the relevant link query in the getItems method within the product repository class. The use of the include method would join the data retrieved from the products database table with related data retrieved from the product categories database table and allow for the products data and related category data to be returned through one query. I'm going to leave the code as it is for now. We'll optimize this code for performance by using the include extension method, as I've just described, toward the end of the course. So if either the products variable is null, or the product categories variable is null, let's return a status code of not found to the calling client code. So in this case, our web API will return a HTTP status code of 404, meaning that relevant data was not found, or a relevant resource was not found. So in this case, it means that the client request failed, and the reason for the failure is that an essential resource could not be found. Else, we want to join the collection of product categories with the collection of products so that we can return a collection of product DTOs to the calling client code, which will include the category name. Remember, the product DTO definition contains a category name property. In order to get the category name for each product in the collection, we need to join the collection of type product to the collection of type product category. We are going to use link for this purpose. In order to avoid creating too many lines of code within our action method, we are going to create an extension method to return a collection type of product DTO to our action method. So let's create a folder named extensions. Let's create a class within our extensions folder named DTO conversions. Note that in order to create an extension method, we need the class that houses our extension methods to be static. Let's create our extension method. So the extension method must be a static method, and we want to return an IEnumerable collection of objects of type product DTO to the calling code. Let's name our method convert to DTO. The first parameter in an extension method must be the type of an object on which we want to be able to call the convert to DTO extension method. So by convention, this parameter definition must also be preceded by the this keyword. So on an IEnumerable collection of type product, we want to be able to call the convert to DTO method in order to convert an IEnumerable collection of type product to an IEnumerable collection of type product DTO. The logic for this method will, using a link query, join a collection of type product to a collection of type product category and return a collection of type product DTO to the calling code. So the second parameter of the convert to DTO method is of a type that is an IEnumerable collection of type product category. Let's write the logic for our extension method. So let's write a link query that joins the collection of type product to the collection of type product category and return a collection of type product DTO. Great. So let's go back to the product controller class and finish the code for the getItems action method. So in order for the convert to DTO method to be accessible on the products variable, we must of course bring in the shoponline.api.extensions namespace. Then let's pass in the product categories variable as an argument to the convert to DTO extension method. Then we can return a HTTP status code of 200 to the calling code. We can do this by returning the results of an OK method, which accepts an argument of a collection of type product DTO. So this code returns a HTTP status code of 200 as well as a collection of type product DTO to the calling client code. So if for some reason an exception occurs during the running of the relevant server-side code, in this case we want our code to return a HTTP status code of 500 to the calling client code, coupled with an appropriate error message. Let's keep the error message simple. Great. So if we open our program.cs file, you can see the configuration code here related to Swagger and Swagger UI. Swagger is an interface description language for describing RESTful APIs expressed using JSON. The configuration relevant to Swagger UI here means that our Web API project is equipped with a basic web-based user interface where we can see relevant information regarding our controllers and action methods. We are also able to use the Swagger user interface to test and debug our action methods when we run our Web API code interactively through Visual Studio. So let's run our code to see this in action. And here we are presented with the Swagger UI. Let's test our getItems action method. We can do this through our Swagger user interface like this. Excellent. In the next part of this video series, we'll write the calling client code that calls the action method that we have written in this tutorial from our blazor component. We'll also write the code to appropriately display the products returned from our Web API component to the user. So in the next tutorial, we'll start to develop our Blazor WebAssembly component. So this is the third part of a video series where we are building a shopping cart application using Blazor WebAssembly and Web API. We are building our application on .NET 6, which at the time of writing this video is the latest version of .NET. We are now at a stage where we have built our database using Entity Framework Core, Code First migrations, and have started implementing code for the first workflow, which simply involves retrieving product data from our database and displaying this product data to the user. In part 2, the previous part of this video series, we implemented the code that retrieves the relevant product data from our database and returns the data to the calling client. This code was implemented in an action method within a controller class named Product Controller. This class was created within our shoponline.api project, which contains the code for our Web API component. In this video, we want to start developing the code for our client-side Blazor component. So in this video, we'll implement code within our Blazor component to call the action method that we developed in the previous part of this video series and display the returned data to the user. So let's get started. The first thing we need to do is copy the URL to our clipboards, which is the URL of our Web API component when we run the shoponline.api project through Visual Studio. We are doing this so that we can appropriately configure our Blazor component to point to the appropriate local Web API URL, so that we can easily test our application through Visual Studio during the development phase of our shopping cart application. One way we can access the relevant URL is to simply run our Web API project. So let's copy this part of the URL, which we can refer to as the base URL or base address, to our clipboards. Then let's open the program.cs class within our shoponline.web component. So here is a block of code that was automatically included within our shoponline.web component, whereby the HTTP client object is configured for dependency injection. This means that we will automatically have access to a HTTP client object from appropriately written classes within our Blazor component. We will be using the HTTP client object to call relevant action methods within our Web API component. So, in order for our HTTP client component to point to the Web API component on our local machines, we need to replace the argument that is currently being passed to the URI constructor here with the base URL that we have just copied to our clipboards. So let's appropriately paste the base URL copied to our clipboards here. Great. So we are going to wrap the functionality that handles calls to our Web API component within services. These services are simply C# classes that wrap the functionality for handling interactions with our Web API component. So the first thing to do is create a folder named Services. Then within the Services folder, let's create a folder named Contracts. Let's create an interface named iProductService within the Contracts folder. So we'll build up the methods for the product service class over time when appropriate during the development of our application. We are just going to implement code for one method in this video. So let's create a method definition for our method in the iProductService file. We want our method to run asynchronously, so our method will return a task object. In this case, we are going to write code to return a generic task object because this method must return a value to the calling code. The type of value that we want to return to calling code is an IEnumerable collection of objects of type productDTO. Let's name this method getItems. In a bit, we'll implement code for this method to retrieve relevant product data from the appropriate action method that resides within our Web API component. We have a red squiggly line under productDTO. The productDTO type is defined within the shoponline.models project, so let's create a project reference to the shoponline.models project. Let's then bring in the namespace for the productDTO type. Great. Okay, so let's create the code to implement our iProductService interface. So let's create a class named productService directly within the Services folder. Let's create a constructor. So we want to tell .NET, as it were, that we want a HTTP client object to be injected into our product service class. So to do this, we simply define a parameter of type HTTP client within our constructor definition. Then let's generate a read-only member variable to reference the object of type HTTP client that will be injected into this class at runtime. The next thing to do is to implement the iProductService interface. So let's write the code for this. Let's generate the code stub for the method that we have defined within the iProductService interface. Let's write the code logic for the getItems method. Let's first generate a try-catch block. Within the try block, let's write code to call the getItemsAction method that resides within the product controller of our Web API component. You can see we are using the generic getFromJSON async method to call the appropriate action method within our Web API component. We are passing in a type argument, which is an IEnumerable collection of type product DTO, to the getJSON async generic method. We are doing this because we want our getFromJSON async method to return an IEnumerable collection of type product DTO. So this method will translate the data, which will be in JSON format, returned from the Web API component, into an object of type IEnumerable, which is strongly typed with the type product DTO. Notice that we are passing in text here, which denotes where the collection of resources that we want to retrieve from our Web API component can be found. The Web API component will know, as it were, to invoke the getItemsAction method within the product controller class of our Web API component, based on this information passed as an argument to the getFromJSON async method. We have a red squiggly line under getFromJSON async. So to get rid of the error flagged by the C# compiler, we must bring in the system.net.http.json namespace. This is where the getFromJSON async extension method resides. The getItemsAction method that we are calling in our Web API component will return a collection of objects of type product DTO in JSON format. The JSON data will automatically be translated into an IEnumerable collection of objects of type product DTO for us. So our products variable here will reference the returned result, which will be an IEnumerable collection of objects of type product DTO. So we could add additional code to handle the HTTP response returned from the Web API component. We'll look at writing code for this when we look at exception handling in more detail in a later tutorial. For now, I just want to go through the basics of returning data from the Web API component and displaying the data to the user from code created within the Blazor WebAssembly component. So now we are going to create our Razor component, where we will create the code to display the data to the user, i.e. the data returned from the service functionality we have just created. Razor components are fundamental to Blazor. Simply put, Blazor apps are built using Razor components. So within the Pages folder, let's create a Razor component named products.razor. Note that we are able to create our code to call our service functionality directly within our Razor file within the code section here. In the interests of creating cleaner code, we are going to abstract the code for consuming our service functionality within a base class. Our Razor component will then inherit from the appropriate base class. So let's create a C# class named productsBase. So in order for our base class to be inherited from our Razor component, our base class must inherit from a class named componentBase, which resides within the Microsoft.ASP.NET Core.Components namespace. So let's go to our Razor file. We want our products.razor component to be invoked when our application is first loaded. So we can ensure that this happens by declaring information about our Razor component's root at the top of this page, like this. Note that when a Razor component with an @page directive is compiled, the generated component class is provided a root attribute specifying the component's root template. Here we are just providing a /. This means that when the URL contains only the base URL for our Blazor component, that our products.razor component will be invoked. And now we can write code within our Razor file that declares that our products.razor component inherits from the products base class, like this. So let's go back to our products base class. Let's create a property to facilitate dependency injection of an object of type iProductService into our products Razor component. So let's define a public property of type iProductService named productService. So to indicate to .NET that we want an object of type iProductService injected into this property, we need to decorate the appropriate property with the inject attribute, like this. And of course, we mustn't forget to register our productService class for dependency injection. So to do this, let's open the program.cs class and implement the relevant dependency injection configuration code like this. Great. Let's create a public property to expose an IEnumerable collection of objects of type product.dto. This collection will be accessible to the relevant Razor code that we'll implement in a bit to output the product data. So now we want our code that retrieves our product data from the server, our Web API component, to run when the product's Razor component is first invoked. We can do this by overriding a function named onInitializedAsync. So to override a method, we can type override, press the spacebar, and then select the method that we wish to override. We want to override a method named onInitializedAsync, so let's select the appropriate item here. The onInitializedAsync method is associated with a Blazor lifecycle event. Let's read a little bit about lifecycle events on this Microsoft Docs webpage. The Razor component processes Razor component lifecycle events in a set of synchronous and asynchronous lifecycle methods. The lifecycle methods can be overridden to perform additional operations in components during component initialization and rendering. If the component is rendering for the first time on a request, create the component's instance. Perform property injection. Run setParametersAsync. Call onInitializedAsync. If an incomplete task is returned, the task is awaited, and then the component is rendered. So within the onInitializedAsync method, let's implement the code for retrieving our product data from our Web API component, like this. We are using the object of type iProductService that will be injected into this class at runtime to return the relevant product data to our product component. Let's implement code for outputting the product data. So if the product's property is null, i.e., has not yet been retrieved from the server, we can output a loading indicator to the user. So while the data is being retrieved, this loading indicator will remain on the user's screen. Else, when the relevant product data has populated the product's property, We want code to execute that outputs the product data to the user in an aesthetically pleasing style. Let's bring in the namespace of our product DTO class. We can include this using directive in the _imports.razor file here. And this means that this using directive will apply to the other Razor files as well. Let's write a link query here that sequentially takes 4 items at a time from the collection of product DTO objects. Images relevant to each of the products has been uploaded to GitHub. Please feel free to download these images. Each image maps to a row of data in the products table in our database. We seeded our database with the relevant data in the first part of this video series. Let's then implement code to appropriately output the product data. Bootstrap 5 is being used to output each item of product data as a Bootstrap card. Later, we are going to abstract this code further to clean up the code a bit. The final code for this functionality is available on GitHub. The appropriate link can be found below in the description. For now, I just want to write code to display our product data appropriately to the user. It was pointed out in the comments section that my spelling of the word furniture is incorrect, both in the Shop Online DB context class and the sidebar in the prototype shopping cart application that I created in preparation for this video series. I don't know why I spelled furniture with an A like this, furnature, but clearly that's what I did. The consequence is that after you ran the migration to create and seed your database, the word furniture may be incorrectly spelled in your products database table and your products category database table. Of course, you may have spotted this and fixed this before creating and running the relevant migration. If not, the good news is that this is easy to fix. I thought that fixing this issue gives us a great opportunity to see how easy it is to fix issues like this during the development phase of our application using EF Core migrations. We can fix the relevant data simply by correcting the spelling issue within the onModelCreating method in the Shop Online DB context class. We can then generate a migration that will contain the code that can be used to update the database with the relevant fix. So if you ran your migration where the word furniture was spelled incorrectly within the onModelCreating method of your Shop Online DB context class, please follow along with these steps to fix the issue within your database. Please note that the appropriate spelling fixes regarding all instances of the word furniture have been uploaded to the relevant GitHub repository. Of course, a link to the relevant repository is included below in the description. So let's open the Shop Online DB Context class that can be found in the data folder within the shoponline.api project. Let's go to the onModel creating method. So let's press Ctrl F so that we can perform a find and replace on the incorrectly spelt word furniture. Okay, clearly I can't even make the excuse that this was a typo. Look at how consistent I've been in spelling the word furniture wrong. Right, let's replace the incorrect spelling of the word furniture with the correct spelling of the word furniture. So, 8 occurrences. And here are some instances where our find and replace did not fix the spelling, because our search was matching the whole word. So let's amend the relevant image file name references for these particular instances. Of course, make sure that furniture is spelled correctly for the relevant furniture folder and the relevant image files on your local machines. I did correct the spelling issue before I uploaded the image files to GitHub, so your file system should contain the correct spelling from when you downloaded the relevant files from GitHub. We can now invoke the Package Manager console window from within Visual Studio and create a migration to fix our issue. So let's create a new migration by typing in the add-migration command. And you can see that the appropriate code to fix the relevant data in our database is generated for us in a new migration class. If we are happy with the relevant migration code, we can run the update-database command to fix the relevant data in our databases. So let's do that. Great. So we are now ready to run our code. In order to run both the Web API component and the Blazor component simultaneously through Visual Studio, we can configure the shoponline.api project and the Shop Online web project to start up at the same time like this. But we want the shoponline.api project to start a little bit earlier. Before we run our code, let's delete the index.razor file from within our pages directory. This Razor component is also configured with the same root as we have configured for our product's Razor component. And we are not going to use the index.razor component that was generated by default in our application. So now when we first run this code, we are actually going to get an exception. I'll explain why in a bit, and then we'll take steps to resolve the issue. Let's press the play button to run the code. You can see here that we have an exception coming from our Blazor component. If we press F12 while our Chrome browsers are active, we can examine the relevant error message here. The exception is caused as a result of CORS, or cross-origin resource sharing. Cross-origin resource sharing, CORS, is a HTTP header-based mechanism that allows a server to indicate any origins, domain, scheme, or port, other than its own, from which a browser should permit loading resources. Basically, this error occurs because our Blazor component has a different base URL to our Web API component. As a result of this, a security barrier prevents us from being able to access the relevant resources returned from our Web API component. Let's copy the base URL for our Blazor component to our clipboards. You'll see why we are doing this in a bit. We are able to configure a policy within our Web API project to explicitly allow for our Blazor component to access relevant resources. So to do this, let's open the program.cs file within our shoponline.api project and include the relevant CORS policy code, like this. So where you see the URLs in this block of code, please paste the base URL for your Blazor component for the relevant URL arguments. Note that we can configure both the HTTP version of our URL and the HTTPS version of our URL in this CORS policy code. And please ensure that you don't include a / character at the end of these URL arguments. Great. Let's run the code again. Excellent, we now have our product data appropriately displayed to us when we first load our application. So all is working fine, but if we look at our product.razor file, we can see that we have written quite a lot of code here. We can make this code that outputs a row of products reusable by abstracting this code into its own component, its own Razor component. By abstracting this code into its own Razor component, we are not only allowing for the relevant code to be reusable by other Razor parent components, we are also creating cleaner code. So to do this, we can create a child Razor component to house the code that outputs the relevant product data. So let's create a Razor component named displayProducts.razor. Let's create a C# class named displayProductsBase, which will of course be the base class for our displayProducts.razor component. Let's make our displayProductsBase class inherit from the component base class. We want a parent Razor component to be able to pass an IEnumerable collection of objects of type productDTO to our displayProducts Razor child component. We can achieve this by creating a parameter property within our displayProductsBase class, like this. It is important to note that a parameter property is decorated with the parameter attribute. let's go to the displayProducts.razor file and implement code to inherit from our displayProducts base class. Then we can go to our products.razor file and cut the relevant code and paste it into our displayProducts.razor file, like this. Then we can modify the code appropriately so that the code within the displayProducts.razor file is traversing the IEnumerable collection passed to the displayProducts child razor component's products parameter. A child component cannot be accessed directly through a browser and therefore does not contain a root declaration. A child razor component must be invoked from within a parent razor component. So let's go to the product's parent razor component and call the child displayProducts child component through this declarative code. Notice how we are able to pass the relevant collection of objects of type product DTO to the product's parameter that we defined within the displayProducts child component. And the code for calling the child razor component from the parent razor component is very much like typical HTML code. By abstracting the code for displaying a list of products to the user into a child razor component, we have created cleaner code, facilitated easier code maintenance, and the displayProducts child razor component can be reused from within other parent components. This will be demonstrated in a later tutorial. Let's run the code. Great. So, let's say that a requirement arises where we need to display each product item under its appropriate product category. So to answer this requirement, we can create an appropriate link query to group our objects of type product DTO by product category, like this. We can also include a category heading for each group of products. And of course, each row containing the grouped products must reside within the loop, like this. Let's also include a dividing line between each product group. Let's run the code. Great! We can clean up this code even further by abstracting the relevant link code within the appropriate base class, like this. Great. And let's say that we only wish to display 4 items for each product category. We can achieve this by using links take extension method like this. Excellent. The last thing I'd like to do is add basic animation effects to each of the Bootstrap cards we are using to represent our products. So to add a CSS class that only applies to a particular Razor component, we can add a style sheet with a name that adheres to a specific naming convention. So let's add a CSS style sheet to the Pages directory and let's name this style sheet displayproducts.razor.css. This naming convention ensures that the styles contained within this file will only apply to the displayproducts.razor component, which is the component that outputs the Bootstrap cards that represent our products. This tutorial is not about CSS, so I've pre-prepared the relevant CSS code. So I'm just going to paste the relevant code into the displayproducts.razor.css file here. This code is of course accessible from within the relevant GitHub repository. Let's run the code. And you can see that when we hover our mouse pointers over a card, the relevant image scales and a box shadow appears. These basic animation effects have been included to enhance the user's UX. Excellent! So this is the 4th part in a series of videos dedicated to building a shopping cart application on .NET 6 using Blazor WebAssembly and Web API. We have now created our first workflow, which involves retrieving product data from the database and displaying the data to the user in an aesthetically pleasing style. We have built our database using Entity Framework Core. We have implemented code using the repository design pattern within a Web API component in order to return product data from our database to a calling client. In the last part of this series, part 3, we implemented code for our Blazor WebAssembly component to call an appropriate action method within our Web API component using a HTTP GET request in order to retrieve product data from the server and display the data to the user in an aesthetically pleasing style. We want to create functionality to retrieve data for a specific product from the server and display the details of that product to the user. So when the user clicks on a particular product, only the details for that specific product are displayed to the user. The user can then decide whether or not to add the product to the user's shopping cart. A button will be provided within the Razor component responsible for displaying the relevant product's details, whereby a user can click this button and add the relevant product to the user's shopping cart. We'll implement the code for the Add to Cart button in the next tutorial. So let's go to the Web API component. Let's open the product repository class and go to the getItem method. You can see that currently we have a default implementation for this method, which was created when we generated the code stubs through Visual Studio of the iProduct repository interface that we are implementing in the product repository class. So as the name implies, the getItem method returns data regarding a single item. So we can use the findAsync method to retrieve the data pertaining to the product that matches the ID value passed into the getItem method through code like this. The next step is to expose the functionality to a calling client by implementing code that gets executed in reaction to an appropriate HTTP GET request. So we want the getItem functionality to execute when a calling client makes an appropriate HTTP GET request for product data that can be identified in the system with the ID value passed to our Web API component from the calling client. We can implement code that creates an appropriate HTTP response through creating an action method within our product controller class. So let's create a method within the product controller class to return data for a particular product. To speed things up, let's duplicate the getItems action method that we created in the second part of this series and change the code appropriately so as to implement the functionality for the getItem action method. We only want to return data for one object of type productDTO rather than an IEnumerable collection of objects of type productDTO to the calling client. So let's change the return type appropriately. Let's include a parameter named ID, which is of type integer. This ID parameter denotes the ID value of the product data for which the client wishes to have returned from our Web API component. Within the HTTP GET attribute, let's include the appropriate root template information. Our getItem action method contains a parameter of type integer named ID. So for the getItem action method, it is appropriate to pass in an argument of type string to its corresponding HTTP GET attribute that denotes the appropriate root template for this action method. So let's use the product repository object passed into our controller class via dependency injection to call the getItem method that we have just implemented within the product repository class. So if the returned value is null, this means that the resource does not exist. So let's pass a response to the calling client that includes a bad request status code. We can do this in code by returning the result returned from the bad request method, like this. So let's say we also want to include the name of the category under which the relevant product falls in the returned object. As we know, we only have the ID of the category under which the returned product falls within the product entity. We don't have the facility to store any other information pertaining to the product's category within the product entity. So we need to write code to get the category information from the product category entity. We can then include the product information and the category information in an object of type productDTO and return the relevant object of type productDTO to the calling client. So let's implement code for the getCategory method within the product repository class to retrieve data for our specific category based on the category ID passed into this method. Let's then write code within our getItem action method to appropriately call the getCategory method on the object of type iProductRepository, like this. The next step is to write the code that merges the data pertaining to a specific product with the data pertaining to the relevant product's category into one object of type productDTO. in order to write the code for this in a clean way, we can create a convert-to-DTO extension method overload within our DTO conversions class. So the convert-to-DTO extension method currently within our DTO conversions class converts a collection of products and a collection of product categories appropriately into a collection of objects of type product DTO, and returns the collection of objects of type product DTO to the calling code. We want our new convert-to-DTO extension method overload to convert one object of type product and related object of type product category into one object of type product DTO and return this object of type product DTO to the calling code. This is basically so that we can include the relevant product data and the category name within one object. Our product DTO type facilitates this. So we can write code to perform the relevant conversion like this. We can now go to our getItemAction method and call the convert-to-DTO extension method, which is now available on this object of type product, to return the appropriate object of type product DTO to our action method. We can then write code to return a HTTP status code of 200 OK, along with the relevant object of type product DTO to the calling client by appropriately returning the result of the OK method and passing in the appropriate object of type product DTO to the OK method. If an exception occurs for some reason during the execution of the getItemAction method, we have code here that will return a HTTP status code of 500, denoting an internal server error, to the calling client along with an appropriate error message. Great. So let's write code within the blazor component to make an appropriate HTTP call to the server-side code that we have just implemented. So let's open our iProduct service interface. Let's include a method definition for a method where we will implement the code to call the getItemAction method on the server. We want this getItem method to run asynchronously, so we are returning a task object. The getItem method is returning a value, so we must pass the return type as a type argument to the generic task type here. This method contains a parameter of type integer and is named ID. This ID parameter denotes the ID value that is used to identify a specific product. So let's implement the getItem method in the product service class. Let's generate a try-catch block. In the previous part of this series, part 3, we implemented code for the getItems method that uses the HTTP client object's getFromJSON async method to call the relevant server-side action method. This method calls the relevant action method, but also handles translating the returned JSON data into the appropriate object type. I'm going to use the getAsync method to call the relevant action method in our getItem method. This method doesn't convert the returned JSON data to the appropriate object type. We need to write code for this separately. We'll do that in a bit. The getAsync method returns a HTTP response object. So we can use the returned object to first ascertain as to whether our HTTP request to the server was successful. So this code checks that the relevant status code falls within the success range. So if the call is successful, we want code to execute that checks if our HTTP request has returned a response with content. If there is no content returned from the server, we want code executed that returns the default value associated with the product DTO type, like this. So the C# default value for a user-defined type, which is a reference type, will be null. So this is just the way I'm choosing to handle the scenario where the call to the server is successful, but for some reason no data is returned from the server. So when the call is successful and content is returned from the server, we want code to execute that translates the JSON data returned from the server into an object of the appropriate type. Else, if the call to the server is not successful, we want code to execute that handles the exception. So here we are just going to throw the exception at this point. And we can pass the message sent back from the server as an argument to the exception object, like this. Within the catch block, we could implement code to log the exception or handle the exception in an appropriate manner that we choose. Let's implement appropriate code within the getItems method to also include exception handling functionality. So let's create a Razor component within the Pages folder. Let's name this component productDetails.razor. So this is the component where we'll implement the code to display details regarding a specific product. Let's create the base class for our product details component, and let's name this component product details base. Let's implement the code for our product details base class. We want the ID parameter that denotes the identifier for a specific product to be passed into the component. So let's create a parameter named ID that is of type integer. We need to decorate this property with the parameter attribute. We also need to ensure that our base class inherits from the component base class. So we want an object of type iProductService to be injected into our product details component. So we can do this by including a property within our base class of type iProductService and decorate the relevant property with the inject attribute. Let's include a property of type productDTO within our base class, and let's name this property product. Let's include a string property to store an exception message. So we want code to execute when our Blazor component is first invoked. So we can ensure that this happens by writing the relevant code within a method that overrides the onInitialized async method. To generate the appropriate onInitialized async method, let's type in override, followed by pressing the spacebar, and then let's select the appropriate method from the list presented to us. Let's generate a try-catch block. Within the try-catch block, let's appropriately call the getItem method on the injected object of type iProductService. The returned value is assigned to our product property, which we can then access from our productdetails.razor file. If an exception occurs, we want the exception message to be assigned to the error message property. Let's implement code to output details regarding the relevant product. So let's ensure that we include the appropriate root template at the top of the file. We can use the page directive for this purpose, and notice how we are including the ID parameter here. This is because an appropriate ID parameter must be passed to this Razor component when this Razor component is invoked. Let's write the code logic. So while the product property is null and the error message property is null, we want a loading indicator to be displayed to the user. Else, if an error occurs, in which case the error message property will not be null, we want the error message to be displayed. Please note that for the sake of this example, we are writing functionality to display the error message returned from the server to the screen. In a complete application, it would be more appropriate to output a user-friendly, non-technical error message to the user and log the actual error message returned from the server. Else, we want to output the details of the relevant product in an aesthetically pleasing style to the user. And of course, Bootstrap 5 classes are being used here to output the data in an aesthetically pleasing style. Great. Then let's go to the display products.razor file and include the appropriate value for the href attribute within the anchor tag that wraps the cards that represent the products sold in our online store. So we want this link to invoke the product details Razor component. We need to include the appropriate ID value, denoting the identifier for a specific product, within our href attribute value here. Let's run the code. Great! Let's abstract the code that outputs an exception to the user in its own Razor component, so that we can reuse this component from within multiple parent Razor components. This is also a cleaner way of implementing the code that displays an error message to the user. Let's write code to force an exception to occur. So we know that a product with an ID of 1000 does not exist in the system. So in this case, the server will send back a response code indicating that a bad request has been made. Let's run the code. Great! Lastly, it would be better in terms of a user's UX if an appropriate animated loading indicator was displayed to the user while the user is waiting for data to be displayed. So, if we navigate to this site here, we can copy the relevant HTML and CSS code for an animated loading indicator of our choice. These loading indicators here can be used within our application free of charge. So let's select this one. Let's copy the HTML and the CSS code for the loading indicator of our choice and integrate the code within our application. The cleanest way to integrate this code into our applications, in my opinion, is to abstract the loading indicator code within a Razor component. As discussed in the previous part of this series, part 3, we are able to create a CSS file that only applies to its corresponding Razor component by naming the relevant CSS file in a way that adheres to a specific naming convention. So if the name of the Razor component is display spinner, we can create a CSS file that will only apply to this Razor component by naming the relevant CSS file display spinner.razor.css. So we can now reuse the spinner functionality for multiple parent components. I look forward to presenting the next video in this series where we'll create the functionality for adding products to a shopping cart. This is the 5th part in a video series dedicated to building a shopping cart application using Blazor WebAssembly on .NET 6. So we have completed the implementation of 2 workflows. The first workflow involves retrieving the data pertaining to the products sold by our online store and displaying the data in an aesthetically pleasing style to the user. The second workflow involves displaying details for a particular product to the screen in response to the user clicking on a card representing the relevant product. In this video, we'll create the functionality whereby the user clicks the Add to Cart button, which is available on the screen where details for a particular product are displayed. This button click action will result in the relevant product being added to the user's shopping cart. After the user has clicked the Add to Cart button, the user will subsequently be navigated to a screen that displays data pertaining to the products currently contained within the user's shopping cart. So let's get started. So let's first implement the functionality for the server-side code. So let's go to our project that contains the functionality for our Web API component. In the second part of this video series, we implemented the repository design pattern for functionality to handle database interactions regarding the products sold by our online store. So we now want to create the code for handling the database functionality pertaining to the shopping cart. So let's create an interface that contains the method definitions for the shopping cart repository class that we'll create once we have created its interface. So let's create an interface named iShoppingCartRepository. Let's create a method definition for a method named addItem. As the name suggests, the code that we'll implement for this method will add a particular product to the relevant user's shopping cart. Let's add a method definition for a method named updateQTY. When a user first adds a product to the user's shopping cart, the quantity of the relevant product added to the user's shopping cart will be 1 by default. The implementation for this method will involve updating the quantity of a particular product that is currently contained within a user's shopping cart. Let's add a method definition for a method named deleteItem. As the name suggests, the functionality for this method will involve removing a particular product from the user's shopping cart. The getItem method will contain functionality for retrieving data regarding a particular product that is currently in the user's shopping cart. The getItems method will contain functionality for retrieving data for all the products that are currently in a particular user's shopping cart. So let's create a class named ShoppingCartRepository. Let's write code to implement the iShoppingCartRepository interface that we have just created. Let's position our mouse pointers appropriately and press Ctrl+ in order to bring in the appropriate namespace, i.e. where the iShoppingCartRepository interface resides. Let's press Ctrl+ and generate the code stubs for the method definitions that we included within the iShoppingCartRepository interface. So in this video, we are going to implement functionality for 3 of the methods that we have defined within the iShoppingCartRepository interface, namely addItem, getItems, and getItem. Before we do this, let's create a constructor. Let's add a parameter to our constructor that is of type shopOnline_DB_context. By including this parameter, we are indicating to .NET that we want an object of this type injected into our shopping cart repository class at runtime. We have already registered the shopOnline_DB_context type for dependency injection. The shopOnline_DB_context type is the EF Core Database Context object that is used for handling data manipulation and data retrieval functionality in relation to our application's database. So let's implement the functionality for the add item method. Let's first write a link query that ensures that the product that the user is attempting to add to the user's shopping cart exists in the products table. So if the item returned from our link query is not null, we want code to execute that adds the relevant product to the cart items database table. This denotes that the product has been added to the user's shopping cart. So let's implement the code to add the item to the cart items database table. Once we have called the add async method, we must also remember to call the save changes async method. Then we can write code to return the entity that has been successfully added to the cart items database table, like this. If an item is not successfully added to the database, we want code to execute that will return null to the calling code. So, in order to avoid a product being added twice to our user's shopping cart, let's implement code that checks to see if the relevant product already exists within the user's shopping cart. Let's implement the code for this in a private method that returns a Boolean value. Then we can use the private method we have just created, like this, to perform the relevant check. So we have ensured that only one instance of a particular product can be added to the user's shopping cart. Please note that the user will be able to purchase more than one instance of a particular product by appropriately modifying the QTY or quantity field. We'll implement this at a later stage. Let's implement the code for the getItems method. Let's write code that returns the results of a link query pertaining to the products currently stored within the user's shopping cart. Then let's write code for the getItem method. Let's write code that returns the results of a link query, which is data pertaining to a particular product currently stored within the relevant user's shopping cart. Let's add a controller class to the controllers folder. Let's name this controller class Shopping Cart Controller. Firstly, let's create a constructor that contains two parameters, one of type iShoppingCartRepository and the other of type iProductRepository. Let's create two read-only fields to reference the objects that will be injected into our controller class at runtime. Let's of course not forget to register the iShoppingCartRepository type for dependency injection. So let's implement the code for the getItems action method. Let's use our shopping cart repository object to return the items currently stored within the relevant user's shopping cart. If no items are contained within the shopping cart, we want code to execute that returns a HTTP response of no content to the calling client. This is denoted by a HTTP code status of 204. So this means the client HTTP request was successful, but no items related to the client's request are present in the system, therefore no content can be returned to the calling client. So we are returning a collection of type CartItemDTO to the client from the action method. We have just written code that retrieves a collection of objects of type CartItem. We want to return a collection of objects of type CartItemDTO to the calling client. The CartItemDTO type contains additional data regarding the relevant product. We don't have the additional data at this point, so let's use the product repository object to retrieve a collection of objects of type product. We can then write code to join our collection of cart item objects with the collection of objects of type product using a link query and return an appropriate collection of objects of type CartItemDTO to the calling client. So let's keep this code clean and implement a link query in an extension method to return the relevant collection of objects of type CartItemDTO to the getItems action method. Before we do this, let's write code to throw an exception if no products exist within the system, because if there are no products in the system and the user is attempting to add a product to the user's shopping cart, well, this won't make any sense. So this means an exception has occurred. Let's write code in a catch block that returns a HTTP status code of 500 to the calling code. So if for some reason an exception occurs during the execution of the getItems action method, we want an internal server error 500 HTTP response to be returned to the client. So let's go to the DTO conversions class and implement another extension method overload named convertToDTO. We'll be able to call this extension method overload on an IEnumerable collection of type CartItem to perform the relevant conversion functionality. Let's go to our getItems action method and call the extension method we have just created to return the appropriate collection of objects of type cartItemDTO. We can then write code to return this collection to the calling client with a HTTP response status code of 200 OK. Let's implement the code for the getItem action method. You can see here that the code is very similar to the getItems action method, but we, of course, are only returning one item of type cartItemDTO to the calling client instead of a collection of objects of type cartItemDTO. So let's write code for converting an object of type cartItem to an object of type cartItemDTO. To do this, let's go to the DTO conversion class and implement the code for the appropriate extension method overload. We can then call the relevant convert to DTO extension method on the relevant object of type cartItem to perform the appropriate conversion functionality. Let's write the functionality for handling a post request from the client whereby a user is attempting to add a product to the user's shopping cart. So let's write code to call the addItem method on the shopping cart repository object that will be injected into our controller class at runtime. We want to return the newly added item of type cartItemDTO to the calling client. So we can call the same conversion code that we implemented for the getItem method for this purpose. It is important to note that it is standard practice for a post-action method to return the location of the resource where the newly added item can be found. This location will be returned in the header of the HTTP response returned from this method. We can use the createAtAction method to ensure that we are adhering to this standard practice. So the relevant resource can be found at the URI, Universal Resource Identifier, pertaining to the getItemAction method, and we are including the ID of the newly added resource here. And for the final argument, we are including the newly added object, which we have now converted to type cartItemDTO. If you'd like to read more about the createAtAction method, I've included an appropriate link below in the description. And we of course need to decorate this action method with the HTTP post attribute. Let's run the shoponline.api project through Visual Studio and you can see the new action methods and relevant DTOs are present on the Swagger UI webpage. Great. Let's implement the relevant code for our blazor component. So let's go to the shoponline.web project. Let's create a new service class where we'll implement code that interacts with the action methods that we have created within our shopping cart controller class in our Web API project. Firstly, let's create the appropriate interface in the contracts folder for the relevant service class. Let's name this interface iShoppingCartService. Let's create a method definition for the getItems method and the addItems method. Let's create a class named Shopping Cart Service. Let's generate the code stubs for the methods defined within the iShoppingCartService interface. Let's create a constructor for the Shopping Cart Service class. Let's include a parameter of type HTTP client as a parameter within our constructor. This parameter indicates to .NET that we want an object of type HTTP client injected into this class at runtime. Let's implement the code for the addItem method. So basically, this code calls the post-action method that we implemented in the shopping cart controller class. If the response HTTP status code is within the success range, let's check to see if any content was returned. If no content was returned, let's return the default C# value for the cartItemDTO type to the calling code, which will be null. If content was returned from the server, let's return the object representing the newly created shopping cart item to the calling code. This will, of course, be an object of type CartItemDTO. Let's include the relevant exception handling code. Let's implement code for the getItems method. So I'm deliberately including an incorrect URI, Universal Resource Identifier, reference here so that this will force an exception when we run the code. We'll fix this a little bit later after we have run the code that tests how an application handles the relevant exception. This code simply places a HTTP GET request to the getItems action method, and if content is returned, returns the relevant content to the relevant Razor component, i.e., the calling code. Let's go to the product details base class and implement a button click event handler method for the add to cart button. Let's name this click event handler method add to cart underscore click. Let's make sure that we have registered the iShoppingCart service type for dependency injection. Let's implement code that ensures that an object of type iShoppingCartService is injected into the product details base class at runtime. Then our code within the add to cart underscore click event handler method calls the add item method on the injected shopping cart service object to add a product chosen by the user to the user's shopping cart. Let's go to the product-details.razor file and implement the code that calls the add-to-cart_click event handler method. So we have started with the implementation of the shopping cart functionality. We have not implemented user registration or login functionality, i.e. membership functionality, in this application. We could implement code to bring down user-related information from the server when the user first logs onto the system. The information could include the user's user ID and the user's cart ID. So because we haven't implemented login functionality, let's temporarily hard-code the user's cart ID and user ID in a class within the project that contains our Blazor functionality so that we can progress with the implementation of the shopping cart functionality. So in the first video in this series, we seeded the data with data for 2 users. So let's say that we are going to run the code from the perspective of the user that has a user ID of 1 and a cart ID of 1. So we can now pass in the hard-coded cart ID value here, along with the relevant product ID and a quantity of 1. When a user adds a product to the user's shopping cart, by default, 1 instance of that product is added to the user's shopping cart. Let's strategically add some breakpoints in the Blazor project and the Web API project and run the code. And let's invoke the functionality for the workflow that we have just implemented in code by clicking a product that we wish to add to the shopping cart. And then let's click the Add to Cart button. Great. If we look at the cart items database table, we can see an item has been appropriately inserted into the relevant table. Let's test this again. Great! Let's create a Razor component that will be responsible for rendering a collection of product data pertaining to products that have been added to the user's shopping cart to the screen. So let's add a Razor component named shoppingcart.razor. Let's add a base class for the shopping cart Razor component. Let's name this class shopping cart base. Let's implement code for the shopping cart base class. So our shopping cart base class must inherit from the component base class because we want this class to be the base class for the shopping cart Razor component. Let's write code for injecting an object of type iShoppingCartService into our class at runtime. Let's include a property for referencing a collection of objects of type CartItemDTO. This property will be used within the shoppingcart.razor file for code that displays the relevant data to the screen. Let's create the code to override the onInitialized async method, where we'll implement code for assigning the relevant collection of items returned from the server to the shopping cart items property when the Razor component is first rendered. Great. Let's implement the code for the shoppingcart.razor file. Let's include the page directive at the top to declare the root template for our shopping cart Razor component. Let's use the inherits directive to ensure that we are using the shopping cart base class as the Razor component's base class. So while the shopping cart items property is null and the error message property is null, we want a spinner loading indicator to be displayed to the user. If the error message property is not null, we want the relevant error message to be displayed to the user. Else, we want code to run that displays in an aesthetically pleasing style the data representing a collection of products that have been added to the user's shopping cart. We are using Bootstrap 5 classes for styling the HTML elements in our Razor file. Now that we have written the code for displaying a collection of products data for products added to the user's shopping cart, let's write code that navigates the user to this screen after the user clicks the Add to Cart button. So let's go to the Add to Cart _click event handler method within the product details base class and implement the relevant code. So we can use an object of type navigation manager to navigate the user to the relevant screen. So let's write code to ensure that an object of type navigation manager is injected into our Razor component at runtime. Let's then invoke the navigate to method on the navigation manager object to navigate the user to the shopping cart screen. Let's run the code. And an error message is displayed to us. This is because we are forcing a 404 not found error to occur at the moment. We have included an incorrect path to the endpoint that returns the collection of cart item DTO objects within the getItems method of the shopping cart service class. We need to appropriately include a reference to the shopping cart controller name within this URI reference. So let's correct this URI, Universal Resource Identifier, by appropriately including the relevant controller name here. Great. This is the 6th part in a video series dedicated to building a shopping cart application using Blazor WebAssembly on .NET 6. So, we have created 3 workflows. Let's recap. The first workflow involves retrieving product data from the database and displaying the product data to the user in an aesthetically pleasing style. The second workflow involves retrieving details for an individual product and displaying the relevant details in an aesthetically pleasing style to the user. The third workflow involves the user adding a product to the user's shopping cart and the user being navigated to a screen that displays a list of products contained within the user's shopping cart. In this video, we'll create the workflow that involves a user removing a product from the user's shopping cart. Let's get started. Let's start by implementing this server-side code. Let's go to our shoponline.api project and open the shopping cart repository.cs file. Let's implement the code logic for the delete item method. So we can use the ID value that will be passed into this method to find the entity that we wish to delete from the cart items database table. We are using the find async method to find the relevant entity using the primary key field, which is the ID field. If we find the relevant entity, if the item returned from the find async method is not null, we can use the remove method to remove the relevant entity from the cart items database table. Then we mustn't forget to call the save changes async method to commit the relevant change to our database. In order to make this delete functionality available to calling client code, let's create an appropriate endpoint within our Web API component. So let's go to the shopping cart controller class and create an appropriate action method that will call the relevant delete item method that we have just implemented in the shopping cart repository class. Let's decorate our delete item action method with an attribute that declares that this action method corresponds to the HTTP delete verb. So far in the development of our application, we have created endpoints that correspond to both the get and post HTTP verbs. We are about to implement the logic for an endpoint that corresponds to the delete HTTP verb. Let's declare the relevant root template information for our action method by passing an appropriate string argument to the HTTP delete attribute. This information includes a definition for the ID that needs to be part of the URI, Universal Resource Identifier, pertaining to the entity that a client wishes to delete. So we are essentially enabling a calling client to delete a specific resource from the system. Let's create a try-catch block. A simple way to create the relevant code for this is to type try followed by pressing the tab key twice. Let's call the delete item method on the shopping cart repository object that will be injected into the constructor of this controller class at runtime. If the entity that the client wishes to delete cannot be found, we want code to execute that returns a HTTP response code of not found 404 to the client. The information that we want transferred across the network for the relevant entity that the client wishes to delete is of type cart item DTO and not the type cart item that is returned from the delete item method called on the shopping cart repository object. In the previous part of this video series, part 5, we implemented an extension method overload named convert to DTO within the DTO conversions class. This extension method can be called on any object of type cart item. Before we appropriately call the convert to DTO extension method, we must retrieve the relevant product entity from the database, so let's write the code to achieve this. Then let's call the convert to DTO method on the object of type cart item returned from the shopping cart repository class's delete item method to convert the relevant object of type cart item to an object of type cart item DTO. Then let's write code to return a HTTP response code of OK200 to the client along with the relevant object of type cart item DTO. Let's complete this method by writing code that executes if for some reason an exception is thrown during the execution of the code logic within the delete item action method. Let's go to our Blazor component. So let's go to the shoponline.web project. Let's add an appropriate new method definition to the iShoppingCart service interface named deleteItem. Let's open the shopping cart service class and implement the code logic for the deleteItem method.